Ladies and gentlemen, welcome back. First example. So here's you're going to see what the expectation is. It's not the problem's nothing new. You did the same thing on the quiz. You did the same thing on the last few homeworks. Problem says solve for x and explain each step. Here's where it's new. This explain y. And when we get into proofs, proofs are usually called two-column proofs. What we're doing, where there's one column where you show your work and you number your steps. And the other side is where you actually explain why your work makes sense. We're really trying to get into justifications for that you know what you're doing and it's correct. So, proofs typically start with information that somebody hands to you. Somebody just hands it over to you and says, here's some information. That's called a given. So in just about every proof you do, the first thing you write down is just whatever information is given. So I don't know if this is on your paper already, but here it is. You're definitely going to write this down, that it's given. The first statement is usually, first reason is usually because you were given some information. So the reason this is true is because Mr. Hess gave it to me. It's given information. I also gave you the drawing, so technically you could say the drawing is given. You don't have to do that. But the drawing is given here where D is between A and B. Take a second and get that labeled. And you might even want to take your information here and add it to the drawing so you can set up your equation. Now before you jump the gun and try to get right to the last step on here, I'm going to go through this piece by piece. This equation should make perfect sense. If you look at the drawing, you'd go, oh, well, of course, AD, the length of AD, plus the length of DB, the two small ones, add up and give you the big one. Here's what might not be as clear. What's the reason for that? What did we call that formula, that equation, that theorem? No, it wasn't a theorem, it was a postulate. It was a postulate from last week. And you certainly could go back to your 1.2 notes and find it, or you could just recall it here. Think about this. We're adding segment lengths. What's it called when we add segment lengths? Well, that's called the segment addition postulate, your favorite postulate. So this, again, this is what's new. Now we justify where these theorems, where these formulas, where these reasonings come from. Where do we come up with that? This makes sense because we understand the segment addition postulate. It's a good idea. It's a simple concept. Most of you would have skipped that step last week. Now we actually want you to show that step of writing that equation. Most of you would have gone straight to adding the x's and the 18s and the 4s and adding those together in the equation. What I want to do now instead, I want to take AD and replace it with 2x because it said AD is equal to 2x. I want to take DB and replace it with 4 because DB is equal to 4. And I want to take AB and replace it with 18. And I intentionally use the word replace 5 times there, 3 times there, 4 times there to recall what's that property for replacement. And all of you, of course, know from algebra it's called substitution. And I'm referencing my steps on there. It's substitution set up by steps 1 and 2. An equation I had set up in step 1, I now combine with an equation I had in step 2 and write a new equation. And this is not about how fast you can get to the answer. It's about explaining why you're doing it. So we're kind of overkilling these first few basic examples. We get into harder things. You'll want to see all the steps. It'll make more sense, especially if I'm in front of the room. There's no leaps of faith. You don't have to go, how did Mr. Hess do that? Well, you're going to be able to see how I did it by showing my reasoning on here. So we're kind of getting you to slow down your thinking a little bit. And then, of course, you guys know how to solve this thing. Think about how you move the 4 to the other side. Well, 2x equals 14. Mr. Hess just subtracted it. So you notice I'm not actually showing my work for some of those mental math steps. You can show your work. You certainly can do that. What I'm doing is I'm explaining my work, and I'm saying I just did subtraction. To get to this step, I subtracted 4 on both sides. And of course the last step is to get rid of that 2. To get rid of the 2, you divided both sides by 2. Divided the 14 by 2, so I'll just write division over here. Division by 2. You will see in your textbook, when you check your answers at the odds in the back, they will say the division property of equality. It just means you're dividing by the same thing on both sides. So I'm writing it out in a sentence. I want you, as we get through this, you can definitely streamline this and just call this division. You can just call this subtraction. But right now I'm just sort of explaining the whole thing here, sort of the longer drawn out version of it. I like substitution to reference the steps you have on there, and sometimes I ask for that on quizzes. So maybe make that a habit that you reference what steps set up the substitution. So there's example 1. We'll go to a second one here. It's a lot like it. I usually, when I'm in class, I usually make sure I throw this up here and slow people down and say, wait a minute, you could do this a different way, or there's more than one way to do this. Let's all those do this the same way. So here it is right here. Prove that x is equal to 2. I'm giving you the answer to the problem. I don't need you to find that x is equal to 2. I already know that. What I want you to do is explain to me why x is equal to 2. So again, the problem started with information that was given. Your first statement and reason is usually given information. So given info is what I'm going to start with. The end of this thing is down here. I want to get to x is equal to 2, and I want to show every step in between there. And like I said, your brain is going to work faster than your pencil. So you're wanting to jump to conclusions that are probably valid. I just want us to slow down and show those steps on here. So take a minute, read these. You may want to pause this and read this and make sense of the drawing, get your drawing labeled before you move on maybe. Hopefully one of the things you realize when you read D is the midpoint of AB, that's telling you something. D is the midpoint. That's a vocab word that's telling you that this entire length is double the two little pieces. So that's where I've come up with this equation. 2 times the length of AD, 2 times the small one, is equal to AB. There's a lot of different versions of this you could write. You could say that AD is equal to DB. You could have said that DB times 2 is equal to AB. There's at least 3 or 4 different versions you could have written for this. Now over here, think of why this statement made sense. What part of this helped you understand that? Of course, the only reason this made sense is because you understood that the word midpoint meant to cut something exactly in half, to make something exactly half of another thing. So the reason this makes sense is because you understand the word midpoint. You understand the definition of the word midpoint. If you thought midpoint meant that these were pretty, you'd write AD and DB are pretty. Instead, you understand midpoint means to cut it exactly in half, which makes that equation make sense. Just like we did in the last one, we typically would do some replacement here. I'm going to show my next step as a replacement step. I keep the 2. I'm now replacing the AD with what it said it was equal to here, and I'm replacing the AB with 14. Of course, replacement is called substitution. My next step, I'm showing these steps sort of progressively here, and this is why I set this original equation up, because I wanted to use a specific property or show you a specific property, remind you of a property from Algebra 1. What did I do here to get this new equation? How did I get 4x plus 6? Oh yeah, you distributed the 2. So this next reason would be the distribution property. And of course you guys know from there, to move the 6 over, you'd subtract. And here we are at the end. How do I get rid of that 4? I do division. So can you get your words over here to explain that? Substitution set up by step 1 and step 2. And I don't have them numbered here. I probably should. When you're doing proofs on your own, you're not always going to know how many steps they are. And then I distributed the 2, did some subtraction, and the last step was division on there. And again, you can certainly abbreviate this down on your homework to one step, distribution, or one word, subtraction, division. But on your homework, you want to have all your work shown and all your reasons shown in 2 separate columns, neatly, cleanly. Should look pretty similar to this. All right, I'm going to pause this thing and go on to the last part for the next example. You can certainly look at it, start it on your own if you think you can.